Hi, my name is Jordan, and I collaborated with my group members Solomon and Kevin to create what you see here, which is supposed to be a robotic smart forklift for the I-CREAT class. Our forklift includes, per the project requirements, two DC motors, two ultrasonic sensors, the Arduino Uno with the Adafruit motor shields, and a third DC motor to replace the servo motor to compensate for the power of the forklift. So on the right, you can see this is the final drawing for our final assembly, and to the left is our blueprint for the gantry section of the forklift. Altogether, we had about 6 parts that were 3D printed and 3 pieces of acrylic for the enclosure that were laser cut. Everything that was used to hold this entire thing together were screws, glue, hinges, and zip ties. Here is the picture of our final wiring and breadboard of the forklift. And as you can see, there is not much in the way of any breadboarding really. We use the smaller one to be able to chain the power together of the two ultrasonic sensors. And most of it had to do with just wiring it to the Arduino and running the code. Now, as far as testing goes, it was very meticulous and there was lots of troubleshooting involved. And my partner Solomon insisted on embedding the serial monitor into the code to help assist with testing the ultrasonic sensors and judging the distances and seeing if the ultrasonic sensors were essentially doing their job. A big part of the design, too, was also making sure that all of the forklift pieces fit into one another, from the gantry to the load assembly to the forks, and making sure they all fit very well. So a big takeaway from this was the fact that we essentially have almost 3 or 4 weeks to get all of this done, from the planning all the way up until the building, and you don't really realize what is in store for you until the assembly part near the end. Then you have to start considering the things that you haven't considered this entire time up until. The biggest part was how exactly the gantry is going to mount, which, as you can see right here, we figured out we can just use hinges and nail it straight into the enclosure. And once again, just re-optimizing the code and making sure it's performing correctly so it doesn't bump into anything or the forklifts just don't work or just move when they're not supposed to. So a lot of that is figured out almost at the very last minute. And like I said before, a big part of the optimization was making sure the code runs smoothly. And a big thing that we had was that it wasn't quite triggering at the right time, and the forks were going up too far or lowering down too soon. And so there was a lot of testing, and I still don't think we quite got it right, but it definitely performs a lot better than the way the program started. And that's about it. On behalf of my group, I want to thank you for watching, and I hope you enjoyed, and feel free to comment and ask any questions that you think we can answer. Thank you.